Okay, so this is the first question that's on the final exam, and we're supposed to simplify this. And in order to simplify, we need to know the correct order of operations, PEMDAS. And PEMDAS is on the corner of the classroom. Everybody should know that you begin with P for parentheses. Now, parentheses, what they tell you to do is to zoom in and ignore everything else and just do whatever's on the inside of the parentheses. So what is 2 plus 30? 32. So you do that one step and write down the 2 plus 30, write down 32, and then rewrite everything. Okay? Bring down the division, bring down the 4, bring down the minus and the 6. Okay? So now, what is 32 divided by 4? Now, some people are like, wait a minute, shouldn't I bring down the parentheses? If you want to bring down the parentheses, you could. Either way, it's still going to say 32 divided by 4. And we have division and subtraction. So after doing parentheses, you move on to E exponents. There is no exponents, but there is multiplication. Actually, there is no multiplication, but there is division. And that's what M and D stand for. So we need to do division before adding or subtracting. So the correct order is parentheses, exponents, multiplication or division, and finally at the very end, addition or subtraction. So we've already done parentheses. That's doing whatever we can on the inside. And then we move on to division, 32 divided by 4. If you don't know that, use a calculator. That will give you 8. 32 divided by 4 is 8. And then bring down the minus 6, and 8 take away 6 is 2. And that's your final answer to this first problem of your final exam. Is the set of values a function? Why or why not? So on this particular question on the final, they give you a bunch of different groups of coordinates. Like this would be like option A, option B would be some other set of coordinates, option C, other set of coordinates. But I'm just focusing on one set. Is this one set a function? Yes. Why or why not? Why is it a function? Yeah, because the inputs never repeat, right? So what makes it a function is whenever you plug in a number and you get out an answer, if you plug in that same number and get out a different answer, the machine's broken, that would be not a function, that would be just a relation. So in this case, you plugged in a 2, you got out something. Plugged in a 5, got out something. Plugged in a negative 2, plugged in a negative 5. We plugged in a bunch of different inputs, and that is good. That makes it a machine, a function machine. So yes, it's a function. Why? Because you never have the same input that produces two different outputs. Right? If I plugged in a 2, got out a negative 3, and then over here, let's say I had a final coordinate that said 2, negative 8, then that would no longer be a function, that would be a relation. The machine would be broken, right? It's not a function machine because you plugged in a 2, got out a negative 3, plugged in a 2, got out a negative 8, that would be a broken machine. That's not a function, that's just a relation. So obviously this point wasn't there. So this is a perfectly fine function. It works. Any questions there? We need to simplify. Now notice this is not an equation. This is not an equal sign in the middle where you have x's on the left side, x's on the right side. It's not an equation. It's expression. Now whenever you see the word simplify and you have x's involved, then you need to think of two things. First, you need to think distributive property. And the second thing would be combining like terms. That's what simplify means when you have variable expressions, okay? Distributive property, that's really multiplication. Combining like terms is really addition and subtraction, which makes total sense because you always have to multiply before adding or subtracting. So do we have any distributive property? Absolutely. Whenever you have parentheses and there's a number out here with no sign between it, between the number and the parenthesis, that means that you're multiplying. So we need to distribute the multiplication of 6. So I highly recommend circling that 6 and drawing an arrow to the x. Now, if you're comfortable with this, you would just say that the answer is 6x. And then 6 times 2, if you're comfortable with this, you would say positive 12. Right? Now, if you're not comfortable, then actually write it out. Like when I say 6 times x, you could actually write that out. 6 times x. And then when you go 6 times 2, you could actually write that out. 6 times 2, and there's a plus sign right there. But if you're good at it, just 6 times x, it'll give you 6x. 6 times 2, it'll give you 12. Cool? Now, let's do the same for this other set of parentheses with the multiplication of -4 on the outside. So everybody circle that -4 and draw an arrow to the 6. -4 times 6, that's -24. -4 times -8, that is a positive 32 with an X. Again, if you're not too good with your multiplication tables, you're able to use calculators. So no excuses, you guys should get this right. That is distributed property. The next step is combining like terms. Combining like terms is simply adding or subtracting the terms that are alike. So you're going to do the x's with the x's. We have this 6x right here and that 32x right there. And you're going to combine them, right, in your head. You're not going to show any work. You just circle it. 6x plus 32x. What do you get? 38. So we have a 38. 38x, that's 38 x's. And then we're going to combine the numbers with the numbers. Positive 12 minus 24. If you're confused with that, use a calculator. Just type in 12, take away 24. It'll give you a negative 12, right? Logically, or in my mind, what I did is I have $12. I owe $24. I can't completely pay them off. I could pay them off 12, but I'm still going to owe them 12. So there's my final answer, 38x minus 12. Right here, they want us to solve. Whenever you have an equation, yeah, the goal is to get x by itself, but first, simplify the equation. Now, what does it mean to simplify? Simplify means distributed property and combining like terms, right? And you want to do that to each side if there's any, right? So we have an equal sign here. The left side does have distributive property, so let's do that. We're going to distribute 3 times x. 3 times x is just 3x. 3 times -4, or 3 times 4, is 12 with a minus sign in front. So we have simplified the left side. There is no combining like terms on the left side. We're just going to bring down the equal sign and the 9. And then we can move on to step 2 of solving equations. Step 2 of solving equations is to isolate x on one side of the equal sign. So x is clearly on the left side of the equal sign. Let's get it by itself there. I don't want this 3 and I don't want this minus 12. Everybody should know that you get rid of what first? The minus 12 first. You get rid of it by going plus 12, because negative 12 plus 12 is 0. And when you do to one side, do to the other side, plus 12 over here. And you could actually add 9 plus 12. That'll give you 21. So our new equation, the 3x comes down, the equal sign comes down, and the 9 plus 12 is 21. So we're down to our one-step equation here. This is really saying 3 times x equals 21. I don't want the multiplication of 3 in front of the x. So I get rid of multiplying by 3 by doing what? Dividing by 3. Dividing by 3. What you do to one side, do to the other. So your final answer is x equals 7. Thank you so much. Hopefully you guys all get this question right on the final. There's going to be some ridiculously easy questions like this on the final, where it just says, what is the first step of this equation to solve it? What's the first thing I do? Subtract 13, right? That's all I do. Subtract, I mean, that's the first step. So that's what you would select. Subtract 13, right? You want to get rid of this plus 13, you would subtract 13. And that's an actual selection, multiple choice. You're going to, there's going to be like option A, divide by -5. No, you don't do that first. Option B, add 5. No, you don't do that first. Option C, subtract 13. Yeah, that's what you do first, right? So that's that easy. Let's move on. Finally, we get into some more fun equations that we need to solve. And again, step 1 of solving an equation is to simplify both sides. And what does simplify mean? Distributed property and or combining like terms. So there's definitely distributed property in these on both sides. So again, when I say sides, I'm talking about the equal signs left side and the equal signs right side. On the left side, I am going to distribute 2 times 3x, and that will give me 6x. And then 2 times -2, that will give me a -4 or a -4. And that's all I could do on the left side. Then I go to the right side and I distribute this -4. -4 times x, that's a -4x. -4 times 9, positive times a negative is a negative. 4 times 9 is 36. And again, you could use a calculator. Bring down that equal sign. There's your new simplified equation. Now you could worry about the goal of an equation to get x by itself on one side. Now, where's x at? It's on both sides, the equal sign. You don't want it on the left and the right side. You only want it on one side. I am going to get rid of the minus 4 by doing the opposite of minus 4x. That would be a plus 4x, right? What you do to one side, do to the other side, plus 4x. And 6x plus 4x is a total of 10x's. And then I bring down everything else. Bring down the minus 4, the equal sign, and the minus 36. Okay. Now I want to get rid of that, the 10 and the minus 4. Which one do I get rid of first? Always the number that's by itself. Remember, x is what's important. The number with x is kind of important, so hold off on that guy. Get rid of the number that's all by itself. That minus 4, let's get rid of it by doing the opposite, plus 4. And what you do to one side, do to the other, plus 4. You'll end up with 10x equaling negative 32. Final step here is to do what? Divide by 10, because that's really saying 10 times x, and if you don't want that multiplication of 10, you do the opposite of multiplying, which is dividing. So you put that fraction bar, which is dividing by 10. What you do to one side, do to the other. These cancel out. You end up with x equaling, you can't divide 32 by 10. So what we're going to do here is leave it like a fraction. However, we could reduce it, okay? So because they're both even numbers, that's a 32, that's a 10. So I could take half of this and half of that. Actually, I'm going to just jot that down so we all know what we're doing. We're reducing the whole fraction by 2. So our final answer is going to be x equals 16 over 5. Negative 16 over 5. X equals negative 16 over 5. And yes, there will be some equations that have funky fractions like this. Now, if you got the right answer, negative 32 over 10, and you look for the multiple choice answer, it's not going to be there because, of course, they reduce it. You always reduce fractions if possible. Let's move on. We have another equation. Sorry, it's ugly. I wrote it out. We have fractions, and we have x's on both sides. So what would you like to do first? There is no distributive property. There is no combining like terms. It is a simplified equation. But we either choose to start moving x's to one side or getting rid of fractions. What do you say? Getting rid of fractions? I actually would have moved the x's first. But we could get rid of fractions. We'll go with that. Whatever you want. So like I would have probably added x and then added x so it'll cancel out and added x so it'll be a 3x. And then I only have x on this side. And then I'd get rid of the fractions because you'd only have 3 terms in your equation instead of 1, 2, 3, 4. Right? So it would make it a little easier if you got rid of x first, but let's not do that. Let's get rid of fractions just because you guys said so. Now the question is, do you want to get rid of the 2/3 first or the 1/2 first or both at the same time? Both. If I wanted to get rid of both fractions at the same time, what would I have to multiply everything by? By the common denominator of both fractions, okay? Which would be 6, right? It would be 6. Because the common denominator of 3 and 2, that would be 6. Now, let's not confuse people. Let's keep this as basic as possible, even though it'll take a little bit longer. Let's just say you wanted to get rid of the 2/3, right? So you would multiply by 3, multiply by 3, multiply by 3, multiply by 3, multiply everything by 3. Right here, this would cancel out. We would have a 2 left over. And then the second term, instead of 2x, it's going to be a 6x because 3 times 2x is 6x. Bring down the equal sign. On the right side over here, 3 times negative x, that'll be a negative 3x. And over here, 3 times 1 divided by 2, because 3 doesn't cancel with 2, so you have to multiply top with the top and leave it over 2. So 3 times 1 is 3 over 2. So plus 3 over 2. Does that make sense, how I got rid of that first fraction? Now let's get rid of the other fraction, the 3 over 2, this guy, by multiplying everything by what? By 2. So if I multiply by 2, multiply by 2, multiply by 2, multiply by 2, my new equation will become 4 plus 12x equals negative 6x, cancels out, plus 3. Okay? Now that I have no more fractions, I could worry about getting x by itself on one side. Where's the x at? The left side of the equal sign or the right side of the equal sign? It's on both sides. I don't want it on both sides, so let's get rid of one of them. I'm going to get rid of the minus 6x by doing the opposite, plus 6x. What you do to one side, do to the other side. So what do I have left now? I have a 4 plus 18x equals 3. Okay? And now let's get rid of the 4 and the 18. Of course, get rid of the number that's by itself first. I'm going to subtract 4. That cancels out. My new equation reads 18x equals negative 1. And for my final step, I am going to divide by 18 and divide by 18. So x equals negative 1 over 18. Okay? Is there a faster way of doing this question? Yes, there is. Maybe I should go through and do that faster way. Check it out. So there's that same equation. I'm going to begin by adding x and adding x. That way I have only 3 terms in my equation instead of the original 4 terms. And now I want to get rid of both fractions at the same time by multiplying everything by the common denominator of 3 and 2, which is 6 times 6 times 6 times 6. Multiply everything by 6. Okay, so 6 on top divided by 3 on the bottom is a 2, and 2 times 2 is 4. And then 6 times 3 is positive 18 with an x. The equal sign comes down, and you could either divide first then multiply, or you could multiply first then divide. 6 times 1 is 6, divided by 2 is 3. Okay, so there's my new simplified equation, which is the same one that we got down here. So you see how it was done faster, and then you got those same 2 last steps, and you get the same answer. Sorry about that, it took a while. Let's move on. Here's another fun problem. It says evaluate when x equals negative 2. So on these, all you got to do is first rewrite what you see, but instead of the x's, put parentheses. So write it out, negative 3 x squared minus 7x plus 9. You write that out, and then since they tell you that x equals negative 2, go ahead and plug in that negative 2 where the x's used to be at, right there and right there. And then once again, it becomes a PEMDAS question, right? You start with parentheses, but there's nothing to do in parentheses. Obviously, you plugged in a negative 2. You move on to E, exponents, and we do have an exponent. We have a negative 2 to the second power. Now, how does the exponent work? It tells you how many times to multiply that base with itself. So in reality, we have negative 2 times negative 2. What is negative 2 times negative 2? Positive 4. So this is really a positive 4. And then bring down the rest. Bring down the minus 3, the minus 7, the parenthesis, the minus 2, the plus 9. Bring everything down. Now, if you don't use different colored pens, you might make a mistake thinking that this is negative 34. So it's probably a good idea to either put the dot for multiplication or keep the parentheses, or both, the dot and the parentheses, because you need to remember that you're multiplying right there. So on PEMDAS, we already did exponents. After the E on PEMDAS, we have M, which is multiplication, and we do have multiplication right here and right there. So let's begin with the first one, negative 3 times 4, that's negative 12. Then the second one, negative 7 times negative 2, that's positive 14. And then, of course, bring down that plus 9. And now we're at the very end of PEMDAS, just adding and subtracting, A and S. So let's just go from left to right. If you owe 12 and have 14, what do you have left over? You owe 12 and have 14. 2. And then 2 plus 9? 11. That's your final answer for this evaluation problem. All right, label the following function or just a relation, okay? So we have 4 graphs right here, and on the test, I only give you one, right? On the final exam, there's only one graph, and you either say it's a function or a relation. Now, just to review, how could you tell with numbers? Well, for each input, there's only one output. If you plug in a 2 and you get out a 5, and you plug in a 2 again and you get out a 7, then you know if that's a broken machine. That's not a function, that's just a relation. But when you have a graph, you don't have to think about numbers. It's even easier. It's called the vertical line test. So if you go to this first graph and you draw a vertical line, how many times does it touch? 2. 1 right there and 1 down there. That is really saying that for the input of, let's say, 2, you get 2 different outputs. right? So this is like the coordinate, let's say the coordinate 2, 4, and this is like the coordinate 2, -3. So as you can see numerically, you plug in a 2 and you get out a 4 up here. You plug in the same 2 and you don't get out a 4, you get out a different answer, so that machine's broken. We don't need to think about numbers. As long as you draw a vertical line and it touches at 2 spots or more, then it's not a function, it's just a relation. So the first one, you're going to label it R because that's a relation, okay? How about this next one? Is that a function or a relation? Function or a relation? Function. Function, okay? If you draw a vertical line, any vertical line, right? Like, let me just draw one randomly right there. How many times does it touch the red graph? Once. How about here? Once. How about there? Once. How about there? Once. Once. It'll only, no matter what vertical line you have on it, it's only going to cross it once. So this is for sure a function, okay? How about this next one? F or R, function or relation? Relation. Why is it a relation? Because if you draw a vertical line, it'll cross at way more than one spot. You got 1, 2, 3 spots, right? So that's definitely a relation. That's like saying I plug in a -1 and I get out a -1. But then I plug in a -1 again and I get out a 3. Then I plug in a -1 again and I get out a 7, right? So that's all messed up. That's just a relation. How about that last one? That one is a function. Good job, guys. All right. So if you draw any vertical line on that last one, it will only cross it at one spot right there, only 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 one spot, and so on and so on. So it's definitely a function. Let's move on to another question. This one's a little interesting. It's an equation. They want us to solve for x. It is a proportion. What is a proportion? When you have one fraction equaling another fraction. When you have one fraction equaling another fraction, what could you do? Cross multiply. Sas. I hope you remember that, right? So you could cross multiply. All you got to do to help yourself out is put this numerator in parentheses. Okay, so you'll remind yourself to distribute. Okay. Even if you forgot about cross multiplication, you could still get rid of fractions by multiplying by 5, canceling that out. Multiplying by 5, it doesn't cancel. You'd have to multiply 5 times 7, get 35 over 9. And then you could multiply both sides by 9. But that's the longer process of doing it. If you do have one fraction equaling another fraction, then you could cross multiply. What is cross multiply? It's saying that 7 times 5, or 5 times 7, it doesn't matter which order you do it, it's going to equal 9 times the binomial x minus 2, or x minus 2 times the binomial 9. It doesn't matter which order you do it. So I'm going to put 9 times x minus 2. So here's my new equation using cross multiplication without any fractions. So what do I have here? I have 35 on the left side equaling, and I'm going to distribute 9 times x, that's 9x, 9 times -2, that's -18. Here's my new equation. 35 equals 9x minus 18. Now I could worry about getting x by itself on the right side of this equal sign. So I don't want this 9 and I don't want this minus 18. So what do I get rid of first? The minus 18. That's right, the minus 18. Get rid of it by doing the opposite, plus 18. What you do to one side, you do to the other side, plus 18. Okay, so that's going to be 53, I believe, right? Equals 9x. And I need to get rid of that 9 that's being multiplied with x. I need to get rid of the multiplication of 9, so I'm going to divide by 9, divide by 9. And there's my answer. X equals 53 divided by 9. You can't really reduce that. 53, I believe, is a prime number. Yeah, you can't divide that by 2 or by 3. So this is your answer. X equals 53 over 9. Another equation, no, it's not an equation, it's an inequality. You want to solve this inequality. So you want to get x by itself, but the problem is x's are on both sides and you don't have an equal sign. So the only difference between an equation and an inequality, you solve it the same way. You want to get x by itself on one side. If you have any distributed property or combining like terms, you do that. But the only difference is if you multiply or divide by a negative on your last step, you have to flip the inequality symbol. So I want to get x by itself on one side, but I have them on both sides, so I want to get rid of one of them. I always recommend moving your x's to the left side, especially on inequalities. So I want to get rid of that minus 3x by adding 3x. And what I do to one side, I do to the other side. Add 3x. 2x plus 3x is a total of 5x's. The inequality comes down. You end up with a minus 25 on the right side. So what I really have here is 5 times x is greater than negative 25. I don't want that multiplication of 5. So for my last step, I'm going to divide by 5. And what I do to one side, I do to the other side. Divide by 5. That cancels out. My answer is x. Now the question is, do I keep that symbol or do I flip that symbol? Keep it. Now why keep it? Because the only time you flip it, is if you multiply or divide by a negative. Now I know some of us are thinking, oh, that's a negative 25 and I'm dividing. Yeah, but am I dividing by a negative? I am not dividing by a negative, so I am not going to flip that symbol. If this would have been a minus 5 and I divided by negative 5, for sure flip that symbol, but I am not dividing by a negative 5, I'm dividing by a positive number. So it's going to stay exactly the way it is. Okay? Negative 25 divided by 5, use a calculator if you need it, is negative 5. So x is greater than negative 5. What is the inequality graphed here? Okay, so this is on a number line, not on an xy plane. So on a number line, we're thinking of the values on the number line that are either greater than a certain value or less than a certain value. The key to remember that is less is to the left. Greater is to the right. That's right. I said right instead of right. It'll help you remember. Okay, so what value are we talking about? We're talking about negative 8, okay? And it's either to the left of negative 8 or to the right of negative 8. It's to the left of negative 8. So we're going to say that x is less than negative 8, okay? Now, notice that there's an open dot. It's not a solid. It's not filled in all in blue. If it were filled in all in blue, if it were a solid dot, I'd have to put a solid line underneath the inequality. It'd be a less than or equal to. But since it's an open dot, I do not put a solid line underneath it. Okay, so I hope we remember solid dot, solid line underneath it, open dot, no solid line underneath it. Okay, moving on. Are these two lines parallel, perpendicular, or neither? What do you guys say? Neither. Now, it's important to say that in order for you to see the slope, this guy, maybe I should circle it in blue. That's the slope right there. This is the slope right there. In order for you to see the slope, you need it in y equals mx plus b form, or point slope form also. But on the final exam, I think it's mainly when you do parallel or perpendicular or neither, it's mainly in slope intercept form. So because you have them in y equals mx plus b, y equals mx plus b, you could compare those m's, and the m's are not the same, so they can't be parallel. Parallel lines have the same exact slope, and these are not exactly the same. Perpendicular lines have opposite reciprocal slopes. Actually, let me do this. This is straight from our board. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope values. What does opposite reciprocal mean? That the sign changes and the fraction flips. So if you had the slope 1/2, you would change it to a negative 1/2, but then flip it so it'd become negative 2 over 1, which is just negative 2. All right. So if I had 2/3, it would become negative 3/2. If I had 4/5, it would become negative 5 over 4. You change the sign and flip the fraction on perpendicular lines. Now, if they're parallel, same slope. Okay, so with that said, these are not the same, so they're not parallel. These are not opposite reciprocals. They are opposite. This one's positive 2/3, this one's negative, but it didn't flip to become a 3/2. So this is where you would say neither. Neither.